Good morning, children. So, I have already discussed about the magnetic field created by a solenoid. Okay, so today I shall discuss about the next topic, that is electromagnet. But before that, I just want to mention one thing, that I told you that solenoid behaves like a bar magnet, but there are certain similarities between the solenoid and bar magnet, and there are differences between solenoid and bar magnet. Okay, so that point I shall discuss first today. So what is the similarities between solenoid, current carrying solenoid, definitely current carrying solenoid, and a bar magnet? What are the similarities? That both of them produce same kind of magnetic field. Alright, so what is the first similarity? Current carrying solenoid and bar magnet, they produced exactly same nature of kind of magnetic field. Okay, please note it down. Then second point, if you suspend a bar magnet and a current carrying solenoid, both of them will set themselves along the geographic north-south direction. Sorry. Alright. Then, so first and second point, I hope you have noted down. Then the sorry, now the third point. Third point is that what? Both of them, a current carrying solenoid and a bar magnet, both of them, they attract iron fillings, means they exhibit the attractive property. So I am repeating, what are the similarities between a current carrying solenoid and electromagnet? How to write down the point? Okay, first point, current carrying solenoid and a bar magnet produce same kind of magnetic field. Second point, both of them, when suspended freely, set themselves along the geographic north-south direction. Third point, both of them exhibit attractive property. Alright, the way it is given in the book, not given in a proper way. So that's why I am just repeating all the 3 points, and please follow how to write it in your board exam. Okay, these are the 3 similarities between a current carrying solenoid and a bar magnet. Then, next is coming, what are the differences between a current carrying solenoid and bar magnet? That already I have discussed, that current carrying solenoid you can change the polarity, but in bar magnet you cannot change the polarity. Alright, then in current carrying solenoid you can change the strength of the magnet, but in case of bar magnet you cannot change the strength of the magnet. Alright, so what are the 2 differences? That in case of solenoid you can change both the strength of the magnetic field and polarity of the magnet produced, but in case of bar magnet both the strength and the polarity you cannot change. Alright, now I am coming to the next topic, that is electromagnet. Now in electromagnet, what is an electromagnet? Electromagnet is a temporary strong magnet made by sending current through a coil which is wound over a soft iron bar. Alright, means what? Just you see here, you have taken a soft iron bar, then you just wound the coil over it and send current through it. Then what will happen? It will be the soft iron bar, it will be converted into a magnet, that is known as electromagnet. Alright, now electromagnet definition you will not get directly. Just like solenoid definition, you may not get directly in the board exam. You may get just write one word for it. So follow what I am saying, the two statement. First statement, a long cylindrical coil whose length is much greater than its diameter. What is the one word you must use for it? That is solenoid. Alright, but suppose the statement is given like this. A soft iron bar kept within a current carrying long cylindrical coil. I repeat, what is the second statement? Please observe it, follow it properly. A soft iron bar placed as a core within a long cylindrical current carrying coil. What will be the one word for it? Electromagnet. Alright, so that's why the concept of electromagnet means the definition of electromagnet and definition of solenoid you have to learn, but you will get indirect question on these two concepts. Alright, then next, electromagnet, you can make electromagnet, two kind of electromagnet you can make. I-shaped magnet, which is known as the bar magnet. Another is U-shaped magnet, which is known as the horseshoe magnet. All of you know, and from 6th standard you are studying it. Alright, so you just consider the I-shaped bar magnet, and on this one, on this topic, what you will get, the diagram will be given to you and you have to decide the polarity. Alright, so do not skip this concept. Do not skip this concept. Alright, so please follow it properly. Here you see I have taken a soft iron bar, then a coil is wound over it, and it is connected, the two ends of the coil is connected in series with a key, with a ammeter, with a rheostat and a battery. Now look at the battery connection. Positive terminal is connected here. Okay, so you see the current will pass like this. Now very carefully observe the diagram, how the coil is made. The coil, the turn is taken, or the current is going from back to front like this. How it is moving from back to front like this. Okay, so you see the direction of current for all the turn in the downward direction. Now for this kind of diagram, how to determine the polarity. So you just observe. So what you see, what I have done, I am holding the pen. You may use a pen or pencil, a scale, anything, just along the soft iron bar. Then you place your one finger along the direction of the current. So you see, you are placing the finger, I am placing the finger along the direction of the current. Now you see how I am looking at it. I am looking at it perpendicular to it. You see, I am not looking like this. I am looking like it. Perpendicular means your pencil and your finger, the setup should be in front of your eyes, perpendicular to it. Now look at your finger, in which direction current is flowing. The current is flowing in the, if I just show it to you, the current is flowing in the clockwise direction. It means what? Here south pole will be produced. So at the near end, when south pole will be produced, for the other end you don't have to take trouble. Automatically here north pole will be produced. Alright, so please everybody practice this one, how to decide the polarity depending on the direction of current. Alright, 10B girls, 10B students, I have shown you in the offline class, but 10A and 10C girls, you please follow the video and follow the method by using your finger, by using your index finger and a pen or pencil or scale, how you can determine the polarity of an electromagnet. Okay, and these are the frequently asked questions. Even the sample test paper, when I will discuss, that we have got from the council for your second semester examination, you will see several this kind of questions are there. So please practice it. So you see what will happen here, south pole will be produced, here north pole will be produced. Clear? Then next is U-shaped or horseshoe magnet. How to make U-shaped or horseshoe magnet? Just here also you wound coil, the same coil, over the two arms of the U-shaped magnetic material or soft iron you have taken, and the two ends of the coil you connect it to battery, rheostat, key and ammeter. But one thing you have to just be very careful. You see here on the left side, how I have taken the turn like this. You see, look at the arrow from front to back. This is the way I have taken the turn. And then how it is taken to the other side, how the turns are taken to the other side. You see here dotted line I have drawn. Dotted line means what? The back portion which is not visible to you. Okay, that's why it is dotted line. Then the coil is wound like this. Means it is back to front. So what is the concept? On both the sides, you should turn the coil in the opposite direction. If in one side you are turning it in the clockwise direction, in the other it should be anti-clockwise direction. Now you see how to determine the polarity. So I will hold this one like this below my eye. Now you see how the current turn is moving like this. Okay, from front to back. So if I look at it perpendicularly, then my finger is coming in the anti-clockwise direction. So anti-clockwise direction means here north pole will be produced. And if it is north pole, then you see if the current is like this, and if I hold my finger like this and look at it perpendicularly, then south pole is produced. Clear to everyone? So decide the polarity, don't mug up the diagram. Decide the polarity by using your finger and your pen. Alright, now here one thing I just want to prefer, to indicate it. The diagram given in the book, you will see they have taken the two ends in the downward direction and they have made the circuit. And that's why they have got south pole here, north pole here. But how I have drawn the diagram, the two sides are in the upward direction. So that's why it does not matter in which direction the two side is, upside down or it is erect. Alright, but the thing is, depending on the direction of the current, you have to determine the polarity. That's why the diagram given in the book, the polarities, and the diagram I have drawn, the polarities are opposite. Okay, so don't get confused. Is that clear? What is there? You should have a very clear concept in determining the polarity of particular side. Okay, particular end. Clear to everyone? So this is the way you can make I-shaped magnet or U-shaped electromagnet. Alright. Then the next is coming. What are the differences between an electromagnet and permanent magnet? This point is very easy. All of you know from junior classes you are studying. So I am just repeating the topic point wise. First point is that electromagnet, if you consider, electromagnet is made up of soft iron and permanent magnet is made up of steel. This is a very important point. You may get conceptual question on this point. So what is the first point of difference? I said electromagnet is made up of soft iron, but permanent magnet is made up of steel. So the question arises, why soft iron is made up of, why electromagnet is made up of soft iron? Why electromagnet is made up of soft iron? Because soft iron can be, please note down this reason, because you may get 1 mark concept, 1 mark or 2 mark conceptual question on this topic. Why soft iron is used to make electromagnet? The reason is soft iron can be easily magnetized and demagnetized. Alright, what is the reason? Soft iron can be easily magnetized and demagnetized. Clear? Then come to the point. Why steel is used to make permanent magnet? Because steel cannot be easily magnetized and demagnetized. Alright, if you do not write magnetized, does not matter. You have to write the point that steel cannot be demagnetized easily. Or you can write, it is very difficult to demagnetize steel. Just you see, the permanent magnet, we want the magnetism permanently within the magnet. So we do not want the demagnetization, and steel has that property. that it is very difficult to destroy the magnetism. It is very difficult to demagnetize steel. So steel is used to make permanent magnet. Alright. So this is the first point of difference, as well as you may get conceptual question on this point. Then second point, electromagnet, in case of electromagnet, we can change the polarity of the magnet. Then for permanent magnet, polarity cannot be changed. Okay, you can write like this: we can change the polarity of the magnet by changing the direction of current. And in case of bar magnet, you have to write that we cannot change the polarity of the magnet. Then third point, in case of electromagnet, strength of the magnet can be changed by changing the magnitude of the current passing through the coil. In case of bar magnet, strength of the magnet cannot be changed. Is that clear? Then next point, electromagnet is generally stronger than the permanent magnet. Clear? Electromagnet is very strong magnet, but bar magnet we cannot make so strong just like electromagnet. Alright, so these are the 4 points of differences, important points only you have to learn and remember and prepare for your board exam for the differences between the electromagnet and bar magnet. Alright, then the next is coming how we use the electromagnet. Electromagnet generally we use in case of electric bell. So as I said, next one, important use of electromagnet in electric bell. So what is the construction of the electric bell? In the electric bell, you see there is a gong and there is a chamber. This chamber is made up of by fiber or any other non-conducting material, insulated. Then here you see there are 2 binding screws, T1 and T2. Alright, and within the this one chamber, what are there? One by one I am saying. First is S. This S is a metallic strip. Alright, with metallic strip, A is connected, that is armature. At the end of the armature, H, that is hammer. Alright, connected. Then you see, after that, after this metallic strip, there is a adjusting screw that is termed as S dash. What is this portion? This portion is nothing but the adjusting screw. Alright, and then in front of the armature, the electromagnet E is placed. Now you see how the electric connection is made. The binding screw T1, it is connected to the lower end of the adjusting screw. Clear? Then the lower end of the armature, okay, it is connected to the coil. Rather, it is a direct connecting wires only. And how the coil is taken, now the coil is wound over the lower side. You see, it is taken from back to front like this. That's why you see here I have given dotted line, because back part, when it is coming back to front, back portion is not visible. You can see only the front side. So when it is coming back to front, you see in which direction current is? Current is in the downward direction. So here you see these turns. For all the turns on the lower side, current is in the downward direction. Now you see how it is wound over the upper side. Upper side, it is taken from front to back. Lower side back to front and upper side front to back. So front to back when the current is, then you see current is moving in the upward direction. That's why you see the turns, the direction of current is given in the upward direction. Alright. And then ultimately it is connected to the binding screw T2. Clear? Then next, outside this one is kept within a plastic chamber, and then T1 and T2 it is connected to the battery and the key. Alright? B stands for battery and K is the key or switch, anything you can say. Alright? So this is the construction of the electric bell. Right? Now construction of electric bell, you don't have to write in statement. If it comes in exam, what you will get? The diagram. So please practice the diagram along with the labeling. Here I have said verbally what does H stands for, G stands for gong. Okay, but what you have to do, you will draw the diagram, then here you will write down H, then arrow hammer, G arrow gong, S dash arrow adjusting screw. Like that you have to write in the exam if the question comes. Draw a neat label diagram. Okay, so you should practice the diagram. Clear? From the diagram you have got the construction only. Then the next point you have to understand, that is what is the working principle of electric bell. Okay, I repeat, working principle. It is not working. Working principle of electric bell. Electric bell works on the principle of magnetic effect of electric current. So what should be your answer? That electric bell works on the principle of magnetic effect of electric current. So only this statement you have to learn and remember. Clear? The next is coming, how actually electric bell works. Alright, so that point wise I am discussing. You listen to the discussion, understand it, but no need to learn it, because if it comes in board exam, then only working principle of electric bell will come. But you should know that how actually it works. So let us find out what will happen. The moment switch is on, then what will happen? Just see, look at this one, the current, it is completed, circuit is completed, adjusting screw touching the armature and the metal strip. It is touching the armature and the metal strip, and then current is passing through this one, and then through the electromagnet it is passing and going back. It means what? The moment switch is on, electric circuit is completed. Alright, this is the way. If one wants to write down it point wise, then this is the way to write. When the switch is on, electric circuit gets completed. Then next point, so current will pass through the circuit and electromagnet will be magnetized. Alright, second point. Then third point, the moment electromagnet is magnetized, it will attract the metallic strip, the armature. What it will do? It will attract the armature. Alright. So, next point, what will happen then? The armature, it will move towards the electromagnet. When it will move towards the electromagnet, two things will happen. First thing, the hammer will strike the gong, a sound will be produced. Second thing, that it will be detached from the adjusting screw. So, circuit will be broken. Clear? So, next point, as circuit is broken, no current will pass through the circuit. So, when no current will pass through the circuit, what will happen? Electromagnet no longer will attract the armature. Here children do one mistake. They write electromagnet will repel. No, electromagnet will not repel. It will no longer attract the armature. Alright. Not attracting and repelling, there is a difference between these 2 points. So please understand it. Be careful when you are writing it. Okay. What to write? That as electromagnet no longer behaving like a magnet, it will not attract the armature. Alright. So what the armature will do, due to spring effect, armature will get back to its original position. Means what? Again it will touch the adjusting screw. The moment it will touch the adjusting screw, circuit will get completed. So what will happen? Again electromagnet will be converted into a magnet. It will attract the armature. Means whatever steps I have said till now, that will be repeated. Clear? So what is happening? Till the switch is on, the hammer, it will strike the gong. It will go back to its original position. Again come near the gong, strike the gong. So the sound will be produced by the bell. Clear to everyone? So this is the way originally electric bell works. Alright. Then next, another important question and topic related with electric bell is that if you substitute the battery by an alternating source of current, means you just connect it to the power point of the household circuit, then will the electric bell work? So that is the next topic and question. So you first understand it. if you replace it by a alternating source of current, you know that in alternating source of current, the direction of current changes at regular interval. So what will happen when the direction of current will change, then the polarity of the electromagnet will interchange, but it will attract the armature as usual, because you see, it does not depend whether the down one is north, up one is south. Okay, if it is north and south, it will attract the armature. Clear? So so how to write the answer of the question? No, the electric bell. You should not write no. You should write yes. Electric bell will work if the DC source is replaced by a AC source. Alright, this is the first answer. Then second, you have to explain what is the reason. How to write the answer point-wise? If the AC source is used, then the polarity of the electromagnet will change at regular interval, but it will still attract the armature. So, electric bell will continue its working. Alright, so regarding the electromagnet, what are the points you have to learn? What is the definition of electromagnet? Then as I said, the two diagrams means finding the polarity depending on the direction of current. You must practice it at home. You make the own circuit. Okay, just by changing the polarity of the battery, by changing the turn, means one turn you have taken front to back, back to front, like that, and then you practice that how the polarity is decided. The next is electric bell. You will learn the diagram. Then working principle. Working principle is magnetic effect of electric current. And then this one, that whether it will work when AC source is used. Clear to everyone? Now I think one point I have missed, although I have said it, in the differences between, you may not get a direct question like the differences between an electromagnet and bar magnet. You may get the question like this: how to increase the strength of an electromagnet? It is very simple. The strength of the electromagnet you can increase three ways. There are three ways. Please note it down. First point, by increasing the current passing through the coil. Is that clear? Second point, by increasing the number of turns of the current carrying coil. Clear? Then third point, by using a soft iron bar. Instead of any other material, if you use soft iron, then the strength of the electromagnet becomes maximum. Alright? Because magnetic permeability of soft iron is very high. Alright, so as you do not know about the term magnetic permeability, don't have to mention in your board exam, but how to increase the strength of the electromagnet, what I said, the first 2 point is most important one, that by increasing the magnitude of the current passing through the coil. Second is by increasing number of turns. Please do not write only current, please do not write only number of turns. Current passing through the coil and number of turns of the coil. Clear to everyone? So that's all regarding this unit. Thank you, girls.